Mercury. Mercury is the closest planet to the Sun, but if you think that means it's hot all the time, you're wrong. At night, temperatures can plummet to an icy -180 degrees Celsius. During the day, however, they can skyrocket to 430 degrees Celsius. This extreme imbalance happens because Mercury doesn't have a proper atmosphere to regulate temperature. Instead, it has a very thin exosphere, which doesn't maintain heat. Well, apart from temperature, you wouldn't have to worry about weather on Mercury. The real dangers come from solar radiation and the lack of breathable air. In fact, Mercury gets almost 7 times the solar irradiance that Earth receives. As the smallest planet in the solar system, Mercury is full of craters, cliffs, and bumpy terrain, making it a pretty tough place to land as well. The low air resistance doesn't help either. It would make slowing down a spaceship much harder, increasing the chances of a high-speed crash landing. During the daytime is out of the question because of the extreme heat. The latest NASA spacesuits can only handle up to 121 degrees Celsius, nowhere near Mercury's daytime temperatures of 430 degrees Celsius plus. Keep in mind that Mercury's day lasts about half a year due to its slow rotation. Nighttime isn't much better. Temperatures of -180 degrees Celsius far exceed NASA's suit's lower limit of -157 degrees Celsius, so you'd still freeze. Your best bet would be to try landing in the Terminator zone, the area between day and night where temperatures are more moderate. Even there, however, it can be risky as temperatures can change relatively quickly. Venus. Venus is the closest planet to Earth, sitting just 40 million kilometers away. This means the journey there would be relatively short, about 4 months. Its size and gravity wouldn't pose much of a problem, as they're pretty similar to Earth's. The first real issue you'd face, though, would be those beautiful yellow clouds you'd see as you approach the surface. Unfortunately, they're made of sulfuric acid, a highly corrosive substance that would destroy your lungs in seconds. But let's assume you've got a spacesuit advanced enough to filter it out. As you descend to the surface, you'd notice visibility dropping drastically. The atmosphere becomes incredibly thick, made mostly of carbon dioxide, so you wouldn't be able to see much. Then there's the heat, an unbearable 450 degrees Celsius. If that wasn't enough, only about 10% of the sunlight reaches the surface, as it's blocked by the thick atmosphere, so it would be pretty dark on the surface. Moving your arms and legs would be a serious struggle. Even though gravity is nearly the same as on Earth, the air is so dense you'd feel like you're wading through a heavy liquid. With a good pressurized suit, you might last a few seconds down there, but before long, the pressure, about 92 bars compared to Earth's 1 bar at sea level, would crush your suit. And if that didn't kill you, the sulfuric acid you'd start breathing once your suit broke definitely would. Mars. Mars is the second closest planet to Earth and the most habitable of all 8 planets. Daytime temperatures are much less extreme compared to Mercury and Venus, reaching up to a relatively comfortable 20 degrees Celsius. However, the real challenge comes at night or in certain parts of the planet where temperatures can drop as low as -13 degrees. Another big issue, similar to Mercury, is Mars's incredibly thin atmosphere. It's mostly made up of carbon dioxide with only trace amounts of oxygen, meaning there's not that much breathable air. This thin atmosphere also results in low pressure and high levels of radiation exposure, which are both incredibly dangerous. The average natural radiation level on Mars is 24 to 30 rads, which is about 40 to 50 times the average on Earth. On top of that, Mars experiences frequent and extremely violent dust storms, with wind speeds reaching up to 100 kilometers per hour. These storms could pose serious challenges, so any attempt at habitation would require a sustainable, airtight, and well-insulated life support system. Jupiter. Jupiter is the biggest planet out of the 8, and it's one of the hardest planets to land on, primarily because of its extreme radiation levels. Even 300,000 kilometers away, the radiation would start penetrating your suit and you'd be done for. But since that's a boring outcome, let's assume you have a hypothetical suit that can block the radiation. Jupiter's gravity is 2.4 times stronger than Earth's, meaning you'd be falling incredibly fast. As you enter the first layers of the atmosphere, you'd encounter white clouds made of frozen ammonia crystals, with temperatures around -150 degrees Celsius. The winds here are no joke, reaching insane speeds of up to 482 kilometers per hour. If you managed to descend about 482 kilometers per hour through these top layers, you'd reach the deepest point ever explored. This is how far NASA's Galileo probe got back in 1995. Beyond this point, things start getting darker, and both temperature and pressure increase rapidly. Just as a fun fact, the pressure near Jupiter's center is estimated to be about 100 million times Earth's atmospheric pressure. After hours of falling, you might reach Jupiter's inner layers, where you'd encounter a supercritical fluid, a state that's not quite liquid but not gas either. Here, you'd kind of be swimming in this bizarre substance. If you continued further toward the center, you'd encounter metallic hydrogen, an extremely dense liquid that would trap you. But if you somehow managed to get through that, you'd reach Jupiter's core, though we're not entirely sure if it's solid or not. The temperatures here would be about 24,000 degrees Celsius, roughly 4.5 times hotter than the Sun's surface. Saturn. Saturn is the second largest planet in the solar system, with an atmosphere primarily made of hydrogen and helium. The first challenge would be avoiding a crash with one of its 146 orbiting moons. Once you manage that, you'd encounter its iconic rings, which are made of debris from old moons, ice pellets, comets, and asteroids. Let's assume you're either an incredibly skilled pilot or your spaceship is indestructible, so you don't meet your end by smashing into space junk. As you approach Saturn's equator, you'd witness an incredible spectacle of red and purple auras caused by highly energetic hydrogen in the atmosphere. However, this beauty comes with a catch. Hurricane-force winds blasting at speeds of around 1,800 kilometers per hour would make it nearly impossible to stay steady. Trying to enter from the North Pole wouldn't be any better. Up there, you'd face a massive storm so large you could fit 2 Earths inside it. This region also has ammonia clouds similar to Jupiter's and temperatures that can plummet to a bone-chilling -250 degrees Celsius. As you fall deeper through the layers of clouds, the temperatures would start to rise again, eventually reaching 0 degrees Celsius. At this point, while the cold becomes less of an issue, pressure becomes your biggest enemy. It increases to levels comparable to the deepest parts of Earth's oceans. Continuing further, the gases around you would transition into a liquid state. If you somehow survived long enough to reach the center of Saturn, you'd encounter its molten rocky core, which is about 10 times the size of Earth. Temperatures here reach a scorching 107,000 degrees Celsius, more than twice as hot as the Sun's surface, with pressure roughly 1,000 times greater than Earth's pressure. Uranus. Uranus is where planets start getting really far from Earth, making the journey incredibly long. Uranus is one of the 2 ice giants, and the only planet in the solar system that spins on its side. It also rotates faster than Earth, with a day lasting just 17 Earth hours. By the way, being an ice giant doesn't mean the planet is a solid ball of ice. Instead, it means it's primarily composed of elements heavier than hydrogen and helium. Like Saturn, you'd need to avoid a crash with rings. Once you pass them, you'd find yourself surrounded by toxic gas, and the temperature would drop rapidly to below -200 degrees Celsius. This makes it the coldest planet in the solar system. If the freezing cold and poisonous atmosphere didn't get you, you'd descend through the first layer of the atmosphere. Here, things get even worse. The air becomes dense and you'd be pelted by ice pellets. Eventually, you'd reach something truly spectacular, a rain of diamonds, driven by winds of up to 900 kilometers per hour. But once again, there's a catch. The pressure here is about 100 times greater than Earth's pressure, which would ultimately crush you. Neptune. Neptune is the second ice giant after Uranus, and its composition is very similar. Being the farthest planet from the Sun, 30 times farther than Earth, it's incredibly dark. Like Uranus, Neptune is extremely cold in its outer layers, but the inner layers are intensely hot due to immense pressure and heat from its core. Matter of fact, its core is about 7,000 degrees Celsius, which is hotter than the Sun's surface. It also experiences the famous diamond rain caused by high pressure breaking down methane and forming solid diamonds. Neptune's winds are among the most strong in the solar system, reaching supersonic speeds. In many ways, it's basically a twin of Uranus, so there isn't much to add. If you like this video, subscribe for similar ones.